everybody at Bitcoin Open Blockchain Meetup, and we're happy to have Aaron Blankstein here from BlockStack, who's going to do a workshop on how to actually create a BlockStack app. Thank you for coming.
Yeah, there we are. Okay, cool. Everyone, I'm Aaron from BlockStack.
I could get that out of the reasons.
Thanks everybody for coming out. Hopefully these slides are going to work. I've never really found Linux to be that reliable of a platform for giving a talk, but it seems to be working okay. All right, so I want to start by talking a little bit about the web that we have today. So today's web, if you think about like where everybody experiences the web, it's really like an application web. Like when people think about using the internet, they think about using mostly applications, right? They're not really thinking about DNS, they're not really thinking about HTTP, they're thinking about the apps they use on top of that, right? Like Facebook and Twitter. Yeah, and so if you think back, like to maybe what the vision of the web was, or like maybe even in the 90s where we had sort of an early version of the internet, right? People were thinking, okay, we're going to build this platform where it's going to be this massive open platform where like anybody can participate, anybody's going to be able to communicate with anybody else, and it's really going to like open up like a flood of innovation and a flood of like new communication channels for people, right? So when you think about the way that that platform would work, right? You would think of like, okay, let's say there's two people like Alice and Bob, and they want to communicate with each other. Well, they're gonna like communicate with each other over the internet. Each of them is sitting in front of a computer, and like maybe their computers, maybe they're not talking like totally directly with each other, but maybe there's like some, medium that they're speaking through, and otherwise it's like a peer-to-peer system. But that's not actually the way that most applications on the internet work today. So the reality is that we build all of these apps, and these apps have become gatekeepers to our communication, right? So if you have two people, Alice and Bob here, and they want to talk to each other, even though they're talking to each other, both of them have these like really like full-featured devices that they're using, even if they're trying to communicate over like their cell phones and stuff like that. These are actually like really sophisticated devices that should be able to talk to each other. But instead, what we have is like an application in the middle that's like interposing on all those requests. So there's a couple problems with the way this is set up, right? Like, sure, this will work, but like, there's definitely problems. So the first problem is that like when you build these applications, all of like the profit and the power of the network all goes to like one party, right? So the application provider can choose to do things like serve you ads, right? Like this annoying pop-up. I guess ads today aren't actually as annoying as this pop-up, but they're insidious in other ways, right? Like the whole point of advertising is to convince you to buy something that you otherwise wouldn't buy. So yeah, no problem. Yeah, I guess another like major point on ads is that ads end up like governing the content on these platforms, right? So like if you think about like your Twitter feed or your Facebook feed, right? Like Facebook and Twitter don't want to like show you things that advertisers won't pay to put content next to, right? And so that'll like end up affecting what you're actually seeing when you're on the internet. The second problem with the way that these applications are structured today is that if I'm communicating to another person over Facebook, Google, whatever, Facebook and Google, they're actually collecting all of that data, right? So we're building these like huge troves of data, like massive, massive data centers to support these applications. Like when you think about it, we've today built really the largest collection of data in the history of humanity. All just like more or less so that we can like send each other like cute photos that we have or like so that's pretty crazy. And even if you think that like, oh well, these people are somewhat trustworthy, like I'm okay with Facebook or Google seeing all this data. What's the worst that can happen? Well, the reality is like these giant troves of data become like huge honeypots for attackers, right? And when you look at like events over the past couple of years, right, you see these like massive data breaches. Like last summer, 2 summers ago, I don't even remember, but like Uber had a hack, like hackers broke into Uber's database and stole 57 million people's like records, potentially, right? And this was like kind of a drop in the bucket to other data attacks that have happened, right? Like there was like the Equifax leaks, all of these leaks, and they're like mind-boggling when you think about it. Like 20 years ago, it would have been insane to have 57 million people's like records of where they were traveling on a day-to-day basis stolen, right? It would be inconceivable. But that's the world that we live in today. Okay, so how do we do something about it? The answer is we want to build a decentralized platform, right? A platform where you can build applications similar to these centralized applications in a way that's almost as easy as building decentralized applications, but doesn't invite centralization at all, right? It doesn't have these massive stores of data that are owned by application providers and users, things of that nature, right? And so that's what BlockStack attempts to provide, right? So BlockStack is an application platform for decentralized apps. In this application platform, we really have like three major systems. We have a blockchain naming system, which is how you start to establish identity of users. You don't have like a centralized repository of who is who and who's authorized to pretend to be someone at any given moment. We have an Atlas network, which is basically a way to map those names with pieces of data. And then we have Gaia, which is a storage system built on top of this that allows users to sign into an application and designate where their data is going to live, rather than the application provider designating where their data lives. Okay. So at first glance, it might seem a little strange to say that like the first thing that you need in a decentralized application ecosystem is a naming system, right? But actually, like naming is fundamental to all sorts of things, not just applications, but it's like fundamental almost to like building anything in a computer system. But when you think about it in like an application ecosystem, like a big question that you have to be able to answer if you're building an app with a ton of different users is like, let's say Bob comes into the system and Bob wants to speak to me. Oh, thank you. Right. So let's say you're like building an app, right? Bob logs into your app and they want to send me a message, right? So your app has to be able to figure out how Bob talks to Aaron. Okay, so today there's a bunch of naming systems that help applications answer these kinds of questions, right? So when you think about how users even sign into your app in the first place, the answer is usually DNS, right? Like if you want to sign into Facebook, you go to facebook.com. What facebook.com is governed by DNS. It's a centralized sort of bureaucratic system. Once you're actually in the application and you're trying to figure out who's who, right? That's like, that information is determined like centrally, right? So if I send a tweet to @Aaron Blankstein, Twitter knows how to turn at Aaron Blankstein into whatever entry in the database that I hand to Twitter, right? Okay, so if you're going to build like a decentralized naming system, then you need to have like some way to weight names in your system to sort of decentralized identifiers or like, yeah. So you're trying to map names to an entity that owns the name, right? And one thing that blockchains are really good at is resolving who owns a thing, right? And you think about Bitcoin, right? The whole purpose of Bitcoin is to resolve who owns some specific coin or like UTXO, something like that, right? Well, you do the same thing for names, right? If you're building a blockchain for governing name ownership, there's really three types of operations that you need. So one is you need the ability for users to register names without invoking some sort of separate party. You need a way to associate some pieces of data with those names. And you need the ability to like, transfer ownership of the name, right? So like, let's say I have some private key that I use to own and operate a name. I have to be able to transfer that to some other person's private key, right? All right. So very quickly, let me give an overview of blockchains. So blockchains are basically just hash chains of operations. These operations are linearized, generally, and verified by a network with some economic incentives to perform those checks. The classic use case is Bitcoin, where you're trying to figure out who owns what coin and what UTXO. And basically every operation in Bitcoin is just a coin transfer from one address to another, which represents movement of that coin from the ownership, one private key to another. Okay, so in the blockchain naming system, remember there's three operations you need: registration, associating a name with data, and transferring ownership of the name. So name registrations in our system are two-phase. In the first phase, you do what's called pre-ordering the name, where what you do is you submit a payment for a name, and you associate that payment with a hash of the name. And you set the public key that is going to correspond with the name's owner. In the second step, you actually reveal the name that you had previously pre-ordered, right? So basically, all you're doing is announcing the inverse of the hash that you just paid for. Does anyone know why we do two-phase name registration?
If you're at the previous talk, you can't answer.
Yeah, so somebody else can't jump in front of your line and just pay more minor fees to get in front of you.
Exactly, yeah. So basically the idea is that if you just tried to do this all in one operation, right? Operations don't settle immediately on the blockchain. So somebody could see that you are about to pay or about to register a name. They see that this name is actually valuable. And so then they register it really fast, and they could come back and say like, hey, there was this name you were interested in, but like, I got it, so I'll charge you for 5% more or whatever for that thing. So you could like run name registrations. And this prevents that because all you're revealing is a hash when you actually do the payment. Cool. Okay, so the important thing about name registrations is that you're trying to resolve like who got there first, right? So like, let's say you have like two people trying to register the name. You're just trying to order these things. So, oops. Yeah. So basically, the owner of Bob is whoever got there first. Okay, so the goal, the entire purpose of having a naming system is that you get to bind data with that name, right? And so in our blockchain, basically there's two pieces of data that you get directly out of the blockchain. One is the public key that owns that name. Really, you get the hash of the public key, but that's important. And then you also get just like a little chunk of data that tells you a little bit more information about the name, right? So like if I owned the name Bob, I could change like a little bit of data associated with the name Bob. And to standardize this type of data in our system, we use the standard DNS zone files, which are a good way of describing routing data. Okay, so the final thing that you want to do is be able to transfer names. Transferring names is a pretty simple operation in theory. Basically, all you need to do is generate a transaction that looks like the message, please send the name Bob to a new owner, indicated by some public key, PK prime, and you tell the network that like this is a valid operation because you sign it with the current owner's public key, right? Pretty straightforward, kind of similar to how sending an UTXO around works. Okay, so that all sounds great, but when it comes to actually implementing a blockchain, there's some questions you have to answer, right? Most importantly, like how are you securing your blockchain, right? If you think about people who build like proof of work systems, or like people who think they've built proof of stake systems, what you do is you encode all of your operations, you have like a hash chain, and then you need to get like miner support or something like that for people to sort of verify and ensure that you know, the blockchain that people are connecting to is the correct one, right? So when we built our blockchain, we thought, well, we might need to encourage a network of miners to actually verify our operations. Or two. Okay, so instead of actually building an fully independent blockchain, we had this idea to use what we instead called a virtual chain. And the idea is pretty simple. So we say that there's an underlying blockchain, we use Bitcoin, and we say we're going to try to use Bitcoin just for ordering all of our operations, right? So like if you think about the history of transactions on Bitcoin, those are already linearized, right? And so can we use the linearization of Bitcoin operations to also linearize BlockStack's name operations? And the answer is yes. It's pretty simple to do. What we do basically is we take any given BlockStack name operation, encode it into the op return field of a Bitcoin transaction, and then submit it as a Bitcoin transaction. Cool. So we shove all this metadata into the op return field of a Bitcoin transaction. Op return gives you about 80 bytes of data. So you can encode things like the operation that you're currently doing. You can encode things like a name, hash of the name. All of that works fine. When you're encoding like other data strings, it can impose a little bit of a limit, right? So if you're trying to associate the name Bob with some string of data, that poses a little bit of a limit. The other trick we play is that we actually use the Bitcoin network to verify ownership of names. So what we say is like in a register transaction or a pre-order transfer, whatever, we look at the inputs and the outputs of the Bitcoin transaction, and we say that in a register operation, the owner of the name is like the first Bitcoin input, right? So that's the first person who spent on that transaction. And if you're going to do a transfer, the destination is the first recipient on the Bitcoin transaction after the operation. And that way the Bitcoin network will actually check the signatures for us. Okay. So this all sounds great, but there's still a couple of details that need to be worked out in virtual chain. So if you think about what we're doing, we're taking these operations that Bitcoin miners don't understand, we're encoding them into like the metadata field of a Bitcoin transaction, then broadcasting them on the Bitcoin network. What that means is that someone could make a BlockStack transaction that looks valid-ish. It's like syntactically valid, but would be semantically invalid, right? So think about like name registration units, right? So like, let's say I register Aaron.id, and then 5 blocks later, another Aaron that lives down the hall from me registers Aaron.id right after me, right? Both of these could be syntactically legal operations in BlockStack, and both people could broadcast them to the Bitcoin network, and Bitcoin miners would accept both of them because they don't actually care about the metadata in those operations. So how do we resolve this? So we have our own sort of client software, which is actually running our blockchain, which is BlockStack Core. And BlockStack Core is reading transactions out of the Bitcoin network. It's getting those transactions ordered by the Bitcoin network, but it has to actually validate that the transactions encoded, or the metadata in the Bitcoin transactions is valid, right? So the BlockStack Core node would be running along. It sees the first Aaron.id registration, sees that that is valid, so it accepts it into its database, and then it'll see a transaction 5 blocks later trying to register Aaron.id again, and it'll just ignore it, right?
Do you ship that with a Bitcoin node bundled, or do you rely on a Bitcoin node running on the system?
So the answer is basically we rely on it running on the system. Like we have some like Docker definitions and stuff for running them together, but we don't ship our own Bitcoin bundle.
Okay. Yeah, that's good, because if we need a Bitcoin node, I've got a caught up Bitcoin node that we can use if that becomes a thing.
Cool. Yeah. So ultimately, that means that like there's 2 trusted nodes running. One, you have your Bitcoin node that you trust, and then 2, you have your BlockStack Core node, which is actually reading the BlockStack transactions out of your Bitcoin node. Right. Cool. So that's how our blockchain works. But like I said, the 80 bytes that you get in an operator doesn't actually allow you to encode that much data, right? Like we're trying to write zone files, and if you think about the format for a zone file, maybe you're not that familiar with the format of a zone file, but you would blow through 80 bytes pretty quickly. It might not be able to encode anything useful at all in the 80 bytes. So on top of our blockchain, we have basically a peering network, which is just sharing information about zone files, more or less. So rather than storing the data directly into the operator field, you store a hash of that data, and then the Atlas peering network is capable of reversing that hash, right? So associated with Aaron.id is a zone file, but what I do is I'll hash that zone file, store that hash in the blockchain, and then the Atlas network would be able to answer the question, like, what is the zone file associated with this hash, right? So if you were trying to get the zone file for Aaron.id, you would look up the record for Aaron.id in the blockchain, you would see that it has some data hash associated with it, and then you would look up the value corresponding to that data hash in the Atlas network.
Real quick.
Yep.
when you think about, especially within blockchain, there's this notion of there being kind of like this balance between usability and security. So my question to you is, all these kind of operations that you have to be doing to whether it's storing the data, and even, putting a hash out there, and pulling it back and inverting it back to get the data itself, does this kind of cause any kind of frictions as far as performance?
So, the answer there is kind of no, but there's multiple reasons why it's no. So like usually, the first reason, primary reason, is that like mostly when a user is using an application, if they're communicating with a person again and again and again, they cache a lot of this data locally. Right? So you only need to do these lookups the first time you communicate with a given person. So that's sort of the first reason that it doesn't affect performance that much. Second reason it doesn't affect performance that much is basically a lot of these lookups can be very fast, right? So if you are asking a BlockStack core node for some data about a name, it's basically just an index lookup in a SQLite database, and that's really fast. And the Atlas lookups are really fast.
Nice.
Cool. So how does your Atlas network work? It uses a full replication technique. So basically every node in the Atlas network is fully replicating the set of zone files in existence. And it does this through like a gossip replication protocol, where like you figure out who your nearest neighbors are in this network. You sort of poll them for information about what zone files exist, and sort of greedily try to download more zone files. The zone files are somewhat limited in their size, so a zone file can only be up to 40 kilobytes. The reason for that is basically spam and DDoS prevention. So when you have a peer-to-peer storage system like this, sort of the first question or problem that you have is like, what happens if a malicious peer joins the network and just tries to flood it with data? So in Atlas, this is solved by the need for every single, like any new zone file published to the Atlas network has to have been associated with a BlockStack naming transaction, right? So it either has to have been a register or like a data update transaction. So all those require a Bitcoin transaction, and it's actually kind of an expensive Bitcoin transaction because it has an operator field and will usually have more inputs and outputs than a normal Bitcoin transaction. So, depending on the day, depending on the fee rate, it could be like $10 or $20 per 40 kilobyte packet that you're trying to span the network with. So it would be a pretty expensive way to span it. Okay. So if you think about like what these pieces have gotten us so far, so we have a blockchain naming system. So that's a secure way to associate a name with a hash of data. You're going to the Atlas network, which maps data hashes to data. Okay, great. So now we can build applications with that data, right? Let's go back to our picture where we use these guys. Oh, we have Alice and Bob. They can communicate with each other over the internet, but now it's like over the blockchain. Like, isn't this great? Well, actually, not really. Because remember, like I said, it costs like $10 or $20 every time you try to communicate 40 kilobytes. You try to communicate this way. So this wouldn't be great. So instead, you have an application storage system. So we have yet another layer built on top of this. So here the question we're trying to answer is like, okay, so if we want to ultimately get to a place where we have decentralized apps where users are in control of their data rather than the application provider, the question you're trying to answer is, well, can we use these pieces that we have to allow user-operated storage to work seamlessly, right? So the answer is yes. And basically, you need to do two things, right? So one, associated with each username from the blockchain naming system, you have a public key, right? And so you can use that public key to sort of bootstrap trust in pieces of data, even if those pieces of data weren't themselves broadcasted on the blockchain, right? So you can use like standard cryptography techniques to do this, right? You can encrypt with a public key, you can sign and verify messages. So there's a lot that you can do there. The second thing that you need to do to be able to build applications is that you need to be able to figure out where users' data is located, right? So in the centralized world, the answer, like where is Aaron's data, is always very simple, right? It's on a data center that the application provider has chosen and is running a database, right? In the decentralized world, it's hard. But we have an answer to that. And what we do is we use Atlas, right, which is storing zone files. And zone files are themselves just like files with pointers in them. So we use these zone files to point to the user's designated storage locations. And then those designated storage locations, they're actually untrusted, right? So let's say my zone file is pointing to some cloud storage or like some server running somewhere. Other users don't have to implicitly trust that storage provider because all of the data that I'm putting there, I can sign, I can encrypt, things like that, so that when users fetch data from that storage provider, they can actually confirm that that data came from me, or that that data is secret. All right, so the system that we built to make this process a lot easier for applications and users is called Gaia. It's our user-operated storage system, decentralized storage system. It's pretty straightforward. Basically, when you start a Gaia Hub, you connect it to a given storage provider. And we have sort of driver support for different backends, right? So we have just like local file system. So you could start a Gaia Hub up and point it in its local file system so that it's like storing data there or reading data out of there.
Can you elaborate? What exactly do you mean by Gaia Hub?
Oh, okay. So it's basically, so it's a server that is capable of writing data on behalf of a user once they've logged into the application, right? So there's basically just like a standardized interface there where the user knows how to delegate permission to write to applications.
Okay, so this could be running like in the browser. It doesn't have to be.
So the tricky bit with running it in a browser is generally your browser's core settings.
Okay.
So like your browser is fairly unwilling to direct writes to most storage providers.
Okay.
But it'll do reads.
Okay.
So like the way that it works for the most of these drivers is that you do writes through the Gaia Hub, but reads can be served by a different backend. So if I spin up a Gaia Hub and I tell some application like this is where my data is going to be stored, this is how you talk to this particular storage provider. The application is sort of churning along on my client. It's sending writes to this Gaia Hub, but reads can actually be serviced by the backend storage provider. Right? So like if it's pointed at AWS, reads could be serviced by AWS. And that way I don't have to spin up a server either that's capable of handling a read workload, which is usually much more expensive than a write workload. But I could also spin up a Gaia Hub that's like firewall and local only, right? So that writes really can only come from my computer. I don't have to worry too much about like the security policies and stuff like that. Yeah.
Wait, so do you have multiple Gaia hubs for a given address?
You could if you wanted to.
But I mean, they wouldn't be replicas, they would be distinct storage.
Yes.
Okay.
Yeah.
But so you're saying, okay, you can have AWS as like a read hub.
Yep.
But how do you, I feel like I'm missing something. How do you
How do you
write
write
to
to
that?
that? Yeah, so basically, if I wanted to use my AWS bucket as a read location, what I would do is I would start a Gaia server. I would configure it with AWS credentials, and I would indicate to the Gaia server that it should only store information for like the following public keys. And then when I log into an application, I give the application some private key that's credentialed on that Gaia server. And then the application can write to that Gaia server.
Okay, so it kind of proxies the right.
Exactly. So like you can think of Gaia Hub as just like a writing proxy.
Okay.
So like if you're shipping an app like this, you wouldn't. I mean, of course, you're not expecting your non-technical users to like, those. Maybe you give the ones some of them an option to run their own, but like you would probably provide some untrusted Gaia Hub for them to use for your application. Is what you're saying.
Yeah. So I think that there's like a lot of exploration still to be done there on like incentive models for running Gaia hubs, and like potential bad outcomes, right? So if you think about it, like if we live in a world where like application writers or like application providers are incentivized to like run untrusted Gaia hubs for their users, you could quickly get into a world where like you have a return of data silos, right? Where like
Yeah, it's the same thing we came from.
right. Maybe. I mean, you still have like some benefit that the data there is encrypted, it's signed, right? And so there is still some data ownership there. The way that like the vast majority of users today work is that we have like a default Gaia provider that BlockStack operates, and when you onboard in the BlockStack browser, it just like automatically provisions Gaia's space for you. But I think that in the long run, we really want to get to a place where like it's a very heterogeneous network.
Sorry, one more question.
Yeah.
So you said before you could provision the Gaia hub so that it could only write certain keys. Does that mean that you could also provision it? I think this is kind of what you just said, but like you could just do public.
Yeah.
Okay. So that just kind of becomes like an S3 type of interface.
Yeah, exactly.
Okay. Sure. Cool.
So what's the IPFS? That's
Oh
IPFS.
yeah. So we support a number of cloud backends. We support local file storage, and we have like an open, outstanding pull request for supporting IPFS as a backend. The tricky bit with IPFS is that well, one of the assumptions that Gaia makes is that when you write some data, so like let's say I wrote a file called important data.txt, right? I have a way to know a priori where that data lands. Like I want it to land at a URL that ends in important data.txt, right? If you're just using sort of vanilla IPFS, you don't get this property, right? You don't actually know what the IPFS URL for your data is going to be until after the data is already written. You can do the hash. Right? It's content-based addressing. But they do have support for something called IPNS, which does give you sort of the properties that you need in Gaia. So there's an outstanding PR. It just needs a little bit of love and attention. People were like really gung-ho about getting that included in there, and you push hard enough on it, you have that support really good.
Yeah, so like in the one video they showed, I think when you showed, you could basically use a centralized provider like Azure Blob or AWS S3. Also, a decentralized hub like IPFS or Siacoin or whatever the heck
Right.
the other one is in the future.
Yeah,
That's
yeah.
kind of a cool concept.
Right, you can get almost the best of both worlds, right? Where, you're replicating across multiple storage packages.
What's wrong with the content addressing? Like, why is that hard to support? Or
Yeah, so, it has to do with basically the way that the Gaia protocol works, is that like, if you're another user in the system and you're trying to figure out, okay, I want to read a file from Karen, and that file is called foo.txt, right? What it'll do is it'll look up my name, it'll look up my zone file, it'll find my associated Gaia hub, it'll figure out like what address in the Gaia hub it's supposed to go to, and a couple other things that it can figure out by itself, and then it just appends foo.txt, the URL, and fires that off as a GET request, like an HTTP GET, right? Dead simple. There's no multiple rounds of lookup. It's very easy to implement, and you don't need to invoke like some code on a server somewhere, right? Like you can do the read directly. The problem with content-based addressing,
I suppose you're always looking at some particular version, and it's difficult to go to like say what you want the latest version, but you need to know the hash first in order to say what that is.
Exactly.
Okay.
So there are like a lot of tricks you could conceivably play to make content-based addressing work better for you, but basically what you need to do is invent a naming system.
Okay. All right, that makes sense.
Yeah. Cool.
So you basically have to have the index of the hash, like the human name of
Yes.
foo.txt, and then the hash, and then if it changes, foo.txt is the new hash, changes, foo.txt maps the new hash.
Exactly.
So it's a pain in the ass for the developer.
Right.
Yeah.
And so IPNS actually implements that through, or is that other things? It's like core. But IPNS implements that. You could implement something like that.
So that's exactly what IPNS is. That
Yes.
system.
You can implement something like that using Gaia as like sort of a bootstrapping mechanism that you described, right? Where you have like an index of like what all the content hashes are. And then you have like one authorized writer, right? The user who's updating that index, and then everybody reads off of that. But I think that the actual user experience there could be like quite negative, right? Because then you're like worried about synchronization between like the index and different endpoints. So it gets kind of
Let's use it for
cool. So like recap this like 3-tiered structure. We'll walk through like the BlockStack sort of like proof of concept application, which is user profiles, right? So instead of a username, example name, blanksney.id, which actually owns by me. And I wanted to look up a user profile associated with that name. So I asked the blockchain for the data hash associated with blanksney.id. The blockchain returns actually this hash, which is a hash of its own file, and then query Atlas, right? So I query the Atlas network and maps that zone file hash to an actual DNS zone file. This is cut off a little bit, but if you look at the DNS zone file, it tells you a little bit more information about blanksney.id. It tells you how long you can cache the zone file, and it tells you a URL where you can find more information. So this URL, it looks something like https :/Gaia.blockstack.org with a bunch of stuff, and then it ends in profile.json. And otherwise, it's a normal HTTPS URL. Your browser can query this and get more data. So when it actually queries that, that's an actual read from the Gaia storage. And you get a bunch of data that can then be rendered by like a user profile explorer. Yep.
To be clear, that's just like a read from a file system that Gaia
Yes.
has provisioned.
Exactly.
Okay.
Yeah. And for Gaia.blockstack.org specifically, it's like from a CDN. So like, yeah, I think, one of like the wonderful things about this design system is that you can use a CDN to distribute the actual data. And so that all of the reads in the system are actually super fast, right? Because like that profile.json object is stored, it can be cached on the edge cache of the CDN. Cool. Yeah, so on top of all of this, we've sort of built a platform for developers. We have an SDK for building applications using these different components. And this SDK gives you two like high-level things. The first is user authentication. So it's basically a way to sign a user in and verify that they've signed in correctly using the blockchain identifier, their BlockStack ID. So this would be opposed to something like user co-auth. And then once the user is signed in, the SDK tells you how to actually use the user supply storage system. You get like a get file and put file interface where you can do encryption, verification. Yep.
Does it have any of the kind of permissioning that's built into OAuth? I mean, is there any concept of like, oh, these two apps can do things on my behalf?
Sort of, but not really. So like we have the idea of scoping. So like an application requests certain scopes from the user. And those scopes are things like the permission to write on their storage, or the permission to publish their data, right? So that it's like, not only are you writing data just to yourself, but also like you're writing this data publicly. So you like announce in your profile that this app is running on the net.
Well, and there's kind of a second layer, because I've got a BlockStack right now app called Blocking Sign. I'm integrating with the Graphite and Stealth controller apps. So there's kind of ways to share data between the app. You just kind of publish your app public key, just publicly, and then that's kind of like, hey, you just sign all. So when I basically write a document to my system, I sign it with like a stealthy, like a different app's key, and say, hey, this app can use this data. I basically get access to it.
Huh.
So there's ways for apps to kind of interoperate.
Yeah.
Okay.
Yeah, there's like a bunch of freedom within the system, but it doesn't get as complex of a provisioning system as what you get. But you can build.
Yeah, and might not even be necessary.
Exactly.
Yeah.
I would say, yeah. Having used OAuth before, I would say, hopefully not. Cool. All right. So if we like think back to that, like whatever that first slide where Bob and Alice were trying to communicate, and there was just application providers sitting in the middle and imposing all their requests. What all of these pieces get us is the ability to build applications where Alice and Bob are able to communicate with each other. They're not doing peer-to-peer, full peer-to-peer communication, but they're interacting with an application that enables a more decentralized way of communicating, right? So Bob and Alice are communicating through the BlockStack naming system, and through storage systems that they have chosen, right? So if Bob is sending a message to Alice or sending a document to her, right? Bob writes in his storage, and then Alice reads from his storage. And similarly, if Alice is writing something back to Bob, Alice writes to her storage, and Bob reads from her storage, right? So it's not peer-to-peer, but it is sort of more user-controlled. So, yeah, and so the vision is that we're going to go sort of, the future of the web is maybe the original design goal of the web, which is a global decentralized communication platform that anybody can use. Okay, so all of this stuff that I just described, all of that is live today and in code, and it's all open source. You can find that code on GitHub very easily. Also BlockStack.org has a ton of information on it. Yeah, that's it. Questions?
Yeah, like, what would you, with the actual Bitcoin transactions, like, what type of resource would you actually want to provision with that? What are the most common types of resources?
I see. So like when you do
Because that's expensive, right?
to do the Bitcoin transaction,
Yeah, to provision a new resource on the Bitcoin blockchain.
right? So
Wait, so I just looked up in the most recent block where there was a BlockStack transaction. It cost 35 cents to do a name registration, just as a baseline.
yeah,
Yeah.
it's cheaper, much cheaper today than when I made these slides.
Yeah.
Which was the
Like December or
higher
something.
you know?
Yeah.
Well, and it's free for subdomains.
Yes, and subdomains, you can also batch registrations, which reduces the cost a lot.
Right.
So if you go to browser.blockstack.org and you go through the like onboarding flow there, like at the end of that onboarding flow, you get a username. But that username is somewhat different than the ones that I've described here. That username is like sort of sub-provision, like you have BlockStack names, and then BlockStack names are themselves able to provision more names. And with that, you can do like batches of those kinds of operations. So we actually run one that can batch up to like 160 registrations in every Bitcoin transaction. At that point, it's very cheap.
But it's tightly coupled to the value of the Bitcoin. So if we went through another boom, then the registration would become much more expensive per account. A
Yes.
higher rate.
Yeah.
But is it also true that like all you have to register is the name, right? Like
Yes.
once the DNS is done, then you can operate for years without paying.
Yes.
Yeah.
Unless you
Yes.
wanted to change.
Years for life. Right?
Yeah. It's
Yeah.
just, it depends on the namespace.
Yeah.
So like some names are only valid for 2 years and then you have to renew them. Other names last forever, but they're more expensive.
Okay.
Large.
Is that's more of like a business decision that you guys are making, or is that?
No, so it's basically all of these rules, like none of the registration fees go to BlockStack, like they're actually all just burned. So when you pay for when you pay for a name using Bitcoin, what you do is you send the Bitcoin that you're paying for the name for to a black hole address.
Huh. Why is that?
Because it's
Just
I
to
mean,
keep the corporations out.
exactly.
Okay.
Well, the amusing thing here is, as always with these projects, if you don't like it, you can fork it and try to make it better.
Yeah.
You guys have like 3 domain names that are kind of like will be hands off indefinitely.
What do you mean?
Like we were talking about, like you can create your own subdomain.
Right.
Does BlockStack themselves have a repository of kind of like ones that they want to make sure no one else can create, ones that you've already kind of
It's like pre-mined.
Google.blockstack, whatever.
Google doesn't appear to be registered.
No. Yeah, so like
So,
I think in
that's
early days,
interesting.
we did do that.
Yeah.
Like we were like, oh, we don't want people to.
Oh no,
spy.
Google.id is, but I don't know about
Yeah.
dot what.
Google.blockstack.
You've got Werner, right? The Amazon CTO.
Oh yeah, but that's actually it.
Is there a com namespace? Does that be?
No, but you could launch one. It would just cost you today only like $5,000.
Oh, oh.
Yeah.
Wait, so where does that come from? Launching a namespace, like $5,000 seems inordinate given the cost we just discussed. Like what does that link to?
Well, so basically, there's like 3 tiers of naming in BlockStack. There's namespaces.
That's top level domain.
It's a top level domain, and all it really governs is the price of names within that namespace, and the length of time during which those names are valid. They can also actually optionally specify that the namespace creator receives registration fees for names registered in that domain. But that's only valid for the first year, after which you have to start burning again.
Are you gonna auto renew because my users are probably not gonna be savvy enough to say, oh, no, we do after 2
Right.
years.
So-
.id.blockstack.
Yeah, as like a business decision, forcing names to need to be renewed is a terrible decision. Because like basically like you force yourself into a position where like every 2 years, like
It's
you
your
need
entire
to
user
like,
base.
and something needs to happen with your user base, right? Like your user base is kind of like self-destructing, which is like interesting. But the third tier of name types, subdomains, actually don't ever expire. So those, it's not as much of an issue. So like,
So whatever my
users-
name is .id.blockstack, that doesn't.
yeah, that wouldn't expire. Also, names in .blockstack don't expire, so they're more expensive to register. I think like if you were trying to register like Aaron.blockstack, I'm not actually sure if I have that. Do some like link squatting. I think that would cost like $200 or $300 or something.
Then to sell it, you would just give away your private keys.
No, you can transfer the name.
So has anybody tried to use DNS for DNS, like literally doing IP addresses to, like, why wouldn't we just get rid of DNS now?
Yeah, so I think like there are some user level drivers for doing this. Like, what's it, 2 years ago?
This guy runs his own DNS server here, like, you might as well clone it all of the.
Yeah.
He also runs into the issues though with those servers, whether, you know,
Pulling out.
your load balancers, whether they're hitting the right sites.
And how do the zone files get updated if you need to do, like, if you need to change the mapping from names to IP addresses somewhat frequently? Does that require an on-chain
It
transaction?
requires an on-chain.
Okay, so that's probably significant overhead.
It'd be too expensive to clone DNS server.
Yeah, at least in this particular realization.
That's a great
I think,
Because all you really need, I suppose, is you need to know like where to go to talk to the DNS provider, and then they can give you like signed records or maybe have roll their own naming system or something like this. I'm not sure what the best way to do it.
Sign things or
Yeah.
I think one of the sort of tricky issues with DNS, at least today, is that there's a lot of assumptions made by user level applications on your operating system about the way that DNS functions, right? So like Chrome and Firefox browser don't really trust DNS on their operating system. Like they're doing their own DNS in-house.
Hmm.
So if you're trying to replace DNS, I think it's like actually really, really hard to do.
Wait, but I mean, that's gotta be coded somewhere there, right?
But I think in Firefox, right? So you need to modify the user
About
level.
big, you can change Firefox to there.
Okay. So you can change it to look at your local DNS.
This is good ultimately for the user.
Well, there's different levels, too. You can have your host file, but that can also be overwritten by your network settings.
Yeah, getting stuff not to overwrite resolve.conf is actually sort of a hard problem.
We're just going to be proud of that.
Yeah, but
So is there a-
Just plug into an untrusted network, but they have presence over.
Is there an example, like a simple example, which has all the features?
Yes.
Chat app.
Yeah,
Chat,
so if you go to blockstack.org, we have there's 3 tutorials. The one that has all of the features is the storage tutorial. It actually walks through the process of building a microblogging app on top of blockstack. It's like to build something like a Twitter clone, but we don't call it.
So with the storage and everything, what do you do if you want something to disappear that used to exist? Say you sent, between Bob and Sue or whatever, but you no longer want public record of that message, or you want it to destruct.
You would put file, with the name of the file, and no content.
Yeah, you
But
like
you
write
own
no
your storage
content.
bucket by your private.
Okay, so you.
I mean,
would
you
be
can't-
able to
You
destroy-
can't-
There's like a fundamental problem. Like you can't believe if somebody tells you they deleted something, like there's no way for you to be convinced without like inspecting
Yeah.
right? And like, there's also no way of knowing like whether they re-encoded and transmitted it somewhere else. Like, you'd have to have like
That file,
full.
Someone else's public key, they've got a copy of it, so they can just copy it off somewhere forever.
Yeah,
If they wanted to. But at
But
that
I
point,
mean,
if
if
you
a-
gave it to them in the first place, you trusted them.
But if a, a third party intercepts something or, works backwards to figure out.
Oh, they have to break encryption, so this is,
Yeah.
Unless
Let's say-
if you're using ICFS, then the point is for
Still there.
persist, right?
Yeah,
Even
yeah.
if you say you think you did it,
Yeah,
it's still there.
recoverable.
encrypted files, they
Yeah.
have to break, breaks encryption.
So as long as the feature is deleted.
Maybe couple thousand years.
Actually, let's see if I can Oh yeah, here, so I'll show you like maybe an example. You know, it's got both travel stack. Cool. Oh yeah, right, so this is a BlockStack app that's like Instagram. So, it's not that active, it's not as active as like someone's Instagram feed, but like here, this is actually a different ID than I think I'm currently logged in here. And it's like me posting some photos that you all find in.
Brooklyn Boulders.
Boulders, yeah, no.
It's a local, rock climb.
Okay. No, Firefox opens. Login is hard. Here's the problem with doing a lot of things. Right, so now I'm trying to log into that app, TravelStack. And so you'll see, I get this prompt. The TravelStack wants to read my basic info and publish data stored for the app. And I can select which ID I want to log in with. The current ID that I'm logged into this computer on is turkeychili.id. Which, you know, I don't know why, but yeah, so boom, and then you're logged in.
Well, can we go over like where the various resources are coming from? Like, what network calls are being made to do what?
Well, hang on, I have a quick less involved question real quick.
Okay, yeah.
So this, I mean, from a user perspective, like you could hand this out, just say, go to this URL, and because it's all HTTP requests, like
Yes.
someone today, right now, could do that without knowing that BlockStack exists, right?
Correct.
So I built the BlockStack app, and my mom, who doesn't know about computers, is able to log on and actually use it. So yeah.
And so they could then kind of opt into some of the more advanced features. It might just gloss over like, oh, you want an account? Well, where's your storage? Well, here's your default storage. If you care about it in the future, you can move it somewhere else.
Get them set up.
And most people don't care, they'll just use the Azure Blob Storage,
Yeah.
provisioned by
Okay.
BlockStack. So,
That's
yeah.
badass. Okay. Sorry.
I like that we're at this place where like the bar is, can somebody who's not like coming to these meetups use it at all?
Yeah.
Well, my question is for a lot of these applications, it's what's the incentive? It's like, I feel like I've seen, you know, especially in the ICO space, I've seen like a lot, for example, a lot of places, a lot of ICOs, they're trying to take the middleman out of the Airbnb experience. When you could arguably say that, you know, they're rightfully so, you need a middleman in that scenario, or even Twitter or Instagram. It's like, what is the incentive for the end user to really say, I don't want them to know that I posted this photo, you know, in Spain on vacation, so I'm gonna completely migrate over to, you know, a nascent network, doesn't have, you know, all the other hundreds of photos that I took with all the other thousands of followers, you know what I'm saying? It's just like, this conversion is this thing that always still is like, trying to wrap my head around it, as far as getting the user base to actually accelerate the growth.
Like, yeah, like it doesn't seem that add much benefit.
Well, so I took, when I decided to do a BlockStack app, I didn't do the typical use case. I'm like, social network, that doesn't make a lot of sense for me. So I did DocuSign, it makes a lot of sense to me. Like, I see huge enterprises putting super sensitive documents in DocuSign, centralized server, centralized honeypot. So I'm like, that's the second it gets hacked, I'm like, I'm gonna show the show my app and hopefully get less people to use it. Really, a document should be owned by you, and you should give it to somebody with his public key and cryptography and all that shit, you know.
Yeah.
Super makes sense. And then the app rewards mining that BlockStack is doing, kind of gives you that incentive to not do advertising or not collect personal data.
Right.
It'll give you a bootstrap to start doing the app, and then I've got like a second level of monetization where once two parties agree on the state of a document, like they sign a document, I store that hash to the Bitcoin blockchain myself, and I just take the fee off that transaction. You know, just instead of going to a proof of burn, a black hole, you go to my Bitcoin address and basically pay me a couple of dollars, and boom, that hash is stored forever. So that's my
Right.
second layer of monetization is, you know, a fee off of a Bitcoin transaction.
That's pretty
Those
cool.
users need to know like how to use the whole network.
Yeah, so the typical use case, people probably aren't gonna store the Bitcoin blockchain because they don't, probably a landlord thing, renting somebody for a year isn't important enough to store the Bitcoin blockchain. But maybe a huge multi-million-dollar deal. At that point, someone has to be savvy enough to send money to this Bitcoin address, and my UI is gonna be intuitive enough to show them how to do that. But I think most people, if they showed a tutorial video on how to send money to a Bitcoin wallet address, public, address, could be able to do it. It's that important of a document to prove out.
So I think you actually said something very interesting, which was that why would you migrate to another platform if you can't take the things that you've built on that platform with you? And I think if I understand correctly, like some of the abstractions that we're seeing here are around data ownership. So it's not that you leave your data, like if you upload 1,000 pictures to one site, because you have a direct connection to the data backend and the data is signed by you and addressable by you, you can bring those pictures with you to the next app, which may not be a photo sharing app, but may just simply be an app that wants to use those pictures to do, maybe it's specifically for making a collage or something like that.
This represents the last time you will ever have to make that decision.
Yeah, like if I understand correctly, the idea is like you should never have to upload a picture more than one place to have it absolutely everywhere that you go.
Right.
So I think that's like completely, and it's like utterly alien to the current way that the internet service providers manage your data.
Yeah, and another big part too is the privacy perspective too. I've worked in marketing long enough to see that, anything that can be used to track you and figure out your interactions with anything. Oh yeah, you take a look at, most of these sites are using Typekit for their font loading, which all goes back to Adobe Analytics and stuff, and so you can't trust fonts, images, anything like that.
Can't download a font from a CD without Adobe.
Oh, yeah, exactly. And this is how they make money, whether you're paying these people or not, they're tracking your interactions. It might be, aggregated up because they're trying to figure out how to sell a product better to you, but, at some point you are being, followed and tracked. I mean, it might not even be as much as a specific entity you're logged in or something like this. It could be your resolution with your IP address or your unique user agent that's combined with your resolution or something like that, and they can use that to say, hey, we've got a high confidence that this is the same person progressing through these different websites.
This all relies on like BlockStack's abstraction, right? Like on the Bitcoin transaction.
Yes, so there's a number of BlockStack abstractions here that are being sort of relied on by.
Like they couldn't replicate it by, seeing black hole data.
Well, you could just bootstrap from the transactions that are broadcast on the Bitcoin network. Well, you need the zone files. So if the peer network goes down and the zone files are irrevocably lost, then you have a problem. So that's like the same problem that the Bitcoin network has, right? Like if the history of the Bitcoin blockchain is lost, like you can't re-bootstrap.
You could argue this is like a super,
That's the whole point of this.
yeah,
But I
it's a
see
very
all the top
extreme.
apps kind of doing backups, like I want to basically run my own core node and everything.
Yeah.
This is what I plan on eventually doing.
you want heterogeneity in your network, and also a limit on the bandwidth.
Did you already discuss that earlier?
I don't think so.
Like, what is your peer-to-peer network?
Our peer-to-peer network, it looks a little bit different than most other peer-to-peer networks that people usually build. So like usually people build things called DHTs, secret hash tables, which is like, you know, basically forms like a ring, and like these people, they don't actually do full replication. They're just like trying to figure out what portion of the network they're supposed to be storing. Atlas, our peer network, on the other hand, is doing full replication, and it's using like a sort of self-discovering gossip protocol based off of Memorial, where it's like discovering its peers, and then doing like random graph sampling to get like a well-connected network so that it distributes its own cost.
Do you have documentation on
Yes. So if you go to our GitHub, github.com BlockStack core, there's some documentation in there on Atlas. I think there's also some documentation on docs.blockstack.org.
Cool.
Regarding usability, have you guys, private key management, is just staying on devices and laptops? I mean, are you guys thinking about any novel approaches to private key management to make this more usable?
So the way that our browser currently works is that when you like onboard as a user, you generate one master seed, and then there's like a hierarchical derivation wallet based off of that master seed. And that master seed is just like a 12-word phrase. If you're familiar with crypto wallet, generally you get that. There's not a whole lot of innovation from us from that aspect, but for applications that use BlockStack, like they basically inherit that private key. Right? They don't have to re-onboard their users with a new private key. Right? When I clicked sign in to TravelStack, what the browser did was it derived the application's private key.
And you have a really good user experience too, because I know most people only know username and passwords. So when you sign up for a BlockStack ID, it's username and password. They say back up your seed, but you also email something, or you call it what, recovery code or something, but
Yeah.
really it's the backup seed,
So
seed, right?
It's basically just the seed encrypted with the password.
Yeah. So you still got a little brain wallet, so Google can't just take that and be like, I am not you. You got the password brain wallet.
Yeah.
Combined with it.
Is this a non-standard browser or like?
This is a pretty standard browser. It's Chromium with uBlock.
But I mean, when you go,
you can see I'm auto signed in to Google.
so when you go to app.travelstack.club, I mean, that's not a BlockStack DNS then?
No.
That's
So it's
regular
just
DNS.
using regular DNS. So today, we rely a lot on regular DNS. I think that's basically like more of a tactical decision, where like, if you want to work on mobile phones, if you want to work on more browsers and stuff, like, I think you try to bite off sort of manageable chunks of the world. So like you start by decentralizing storage.
But so the BlockStack part of it, someone hits this page and then the server back on the back
It
end.
just serves JavaScript and HTML, so you can run this local host too, or you can wrap it in electronic ship work.
What-
That's how mine works.
I guess what I'm saying is that it's the HTML that it generates that has all of the logic in it. Not the-
Yeah.
It's the
Right.
logic generates the HTML.
And most of them are just single page apps that you can totally just run from
Right.
the web app or client side. This just serves up those static files.
Okay.
Yeah.
So-
And then today, like, there's a bit of trust that you're placing in the application that it's actually client side.
Okay.
So, I mean, it's easy enough to like build a system where you actually jail the application so that it can't make requests outside, but
And just to be clear, I think it almost sounds like
as a user, it doesn't actually matter from the point of view of just signing things and doing asymmetric cryptography that there's a name resolution system. It's more like if I want to talk to you, I don't want to have to know what your key hash is. I want to be able to just write a name, and so I can understand other people on the network via short strings rather than crazy strings. Is that right?
That's exactly right. So basically, the idea here is that like I want to look at Larry.id's travel stack profile. I don't want to look at the like hub
Zero
key
hash.
hash.
Show the network tab, that explains a lot. Just like if you ever tried to sniff out Telegram transactions, you notice everything's client-side encrypted.
Yeah, so
this
the
might
problem is
actually be
there's a lot of,
public, but
there can be a lot of
yeah,
stuff.
sniffing out the network tab on most of these BlockStack apps will explain almost everything.
Yeah,
We're getting a bunch of profile updates.
yeah, so it's doing a bunch of fetching. So here it fetches the first step is it's fetching information about Larry.id. So how to make this bigger? I do know how to make it bigger. No, it's too big. Yeah.
Kill the console.
Okay, so the first request it makes is to a core node. So I was like, it's using core.blockstack.org, which is core node rerun, but you can use a local one if you want. It asks for Larry.id and it returns some data. So here is the address that owns Larry.id. That's a Bitcoin address. It tells you what blockchain it was registered on, Bitcoin, what Bitcoin block it expires at, the last transaction issued on this name, and zone file hash. The zone file gives you this URL. It's the URL to profile object. And then here's the actual profile object. So it's a JWT, which is a JavaScript web token, which hopefully you know nothing about.
I know everything about open. It's nasty. And all those rabbit holes.
If you actually like inspect
All
the
that
stuff
data
that's all being stored in this JWT, so this JWT is basically like a signed object with more data about the name. We use this so that like every time you sign into a new app, you don't have to do a new blockchain transaction, like register more Gaia information. But within that, you have like there's picture, his name, some accounts that are associated with him on like Twitter and stuff like that. But you also have this like apps key, and this apps key just stores like a bunch of URLs that are sort of like the root of that user's data on different applications. So when the application actually like does the lookup for statuses.json or following.json, the URL that it gets there, it's computing by reading the URL right there.
So is there some mechanism for checking to see if you're actually seeing like the latest version of this? So like what if I forget where this is coming from, but some service run by BlockStack. So like what if that gets compromised? Is there any way for you to know that you're getting like an old version, like it's signed, but maybe like the previous version has been updated, like there's a name change or something like
Right.
this?
So there's like different answers for different levels of the stack, which kind of makes sense, right? So from a BlockStack core node, right? Like you can tell that the data it's rendering is stale because the Bitcoin block height that BlockStack core node is reporting is farther back than you have some other information about.
Okay.
You can also determine whether or not that BlockStack core node is on a different fork of BlockStack core, because it Merkle tree over all of the data BlockStack core is about.
Okay.
And so you can tell whether or not like something has happened on that level pretty quick. On the levels above that, so if you look at zone file is basically the same as that level, right? Because you're getting a data hash back and you want to confirm that the zone file you're getting matches that data hash. But when it comes to data out of data storage, right, it's a much harder thing to do to prove that you're not getting stale data. And basically what you have to do is what you have to do in sort of traditional applications if you're trying to do this, and it's basically include sort of timestamps or expirations.
Yeah, I just noticed it's the second to the bottom key on the page is expiration.
Exactly.
Okay, all right.
Couple of questions. So, first of all that data I'm looking at there, that is data that someone would just associate, like voluntarily associate with their identity. Maybe they're storing all that data themselves, and they just put all that in a JSON web token and say, here's all this data associated with me.
Yep.
And those are just like standard web addresses, right?
Yeah, the ones up higher, those are sort of, that's like direct user input, right? So
Okay.
like Larry entered that his address locality is Hong Kong, right? So he inputted that directly. The data in this apps field, that is added by the user client when you click approve, when you sign into an application.
Cool.
But is that
So-
kind of multiple,
Yeah.
right?
Second question is, let's say I go register Hannah.id, right? And I have a key pair associated with that, the key so I can sign things and verify myself. What if I worry that key's been compromised? Is there a way for me to keep Hannah.id but swap out that key pair?
Yes. So what you can do is you can transfer Hannah.id to a new.
And what does that look like on the back end? How is that done? So to register in the first place, you do a Bitcoin transaction, and then that transaction gets ported onto the BlockStack blockchain, right? And then, so is that like the Bitcoin blockchain? Like there's this address that has a key pair associated with it?
Yes.
Okay, and then, so how do I make that transfer?
So it's pretty much the same. So instead of doing a register transaction, you're instead doing a transfer transaction.
Okay,
And it's basically,
so again, it would be on the Bitcoin blockchain?
it's on the Bitcoin blockchain, and it would have to be signed by the original key.
Okay.
Now, if you're worried that your key is compromised, you're at that point in like a race with the compromiser.
Right.
It's like if you think that someone has the private key to all of your Bitcoin, like they can transfer your Bitcoin out just as quickly as you can.
Right.
So you're in like a dangerous scenario.
Okay, so you can transfer, but there's no recovery option.
There is a revoke operation though
Oh.
that I think takes like maybe one block precedence or something. So like if there's a revoke operation in the same Bitcoin block as a transfer operation, I think the revoke wins. Let me double check that. But what you can do is you can say like, I think my ID has been compromised and I'm gonna just kill it.
They're all just CLI right now.
So generating most of these transactions, there's a ton of different kinds, like namespace operations, name operations. Generating most of them is all CLI. We have like a library for doing it as well.
I
So-
saw the videos you put out a few years ago, and it might have been a year or two ago now, where it would be like almost every CLI transaction, but it was so small back, it was like 10, you had like 50 things you can get out in CLI.
Yeah,
So you should get them a video, that was a really good video.
yeah. So I think that like we're like retooling our CLI a lot. And I think once we've sort of finished that retooling process, we'll do another demo on that.
Which library is this? Is it
BlockStack.js.
Oh, okay.
So if you look in /source/ operations, you'll see all the transactions that are in code.
Kind of in continuation with that discussion, I'm picturing building an app on this, and then one of my users somehow gets their account compromised. And they want to make sure that all their friends don't start talking to that other person who's now using their account. If I'm an app developer, is there any way for me to blacklist an account, to say that's a compromised account, even if it's not, or is it all just completely rejected?
Revocation. there's like ways that you could help your users out with things. So like, I think that one of the things that we sort of think a lot about is like, you know, if we're living in this like permissionless communication world, right? Like, I don't necessarily want to receive communications from all sorts of people, right? But I can do like client side, like, right? So I could have like a blacklist or a whitelist that's client side and enforced by my client, right? Not some, not like a provider or something like that. And like, if you're an application writer, you can implement a lot of that functionality in your application for the users. Like you could say like, you know, this guy's doing like this,
So how big are these JWPs that you generate?
Uh,
And how big will they grow, and will that cause issues with, header size and something like 700 hex?
Oh, well, so these JWPs, the profile JWP, it doesn't actually get, transferred in headers. Like,
Oh,
this is the actual response.
So it's not used as like a traditional
No,
authorization?
it's not like an auth token. So like the auth token that goes into the header, that is also a JWP, but it's a different JWP and one that doesn't have the same like load characteristics.
I mean, you could just ship like a, what is it, a 64 byte ECDSA signature and then have the client like look up the corresponding token from some endpoint.
Yeah, but, traditionally, the purpose of a JWT though is to provide that and be able
Yeah, to be integrated.
So that.
But if
way
it
you're
ends
not
up being like a
reliant on
huge
individual
document,
Call out, so,
Mm. I mean, it's just like if it ends up being a gigantic document, then
yeah,
it's harder to justify it being like, at least you'd want to have like, ship it in smaller chunks or something.
Or be able to make a call out and say, hey, this is the app that I'm, requesting the token for, and have it kind of to that general, audience or whatnot. So,
Yeah, we used to include the user's profile in, so like when you authenticate, when a BlockStack app authenticates with the browser, right, it initiates this like two-step, three-step thing, right, where it generates an authentication request. That authentication request is a JWT and it's URL encoded, and so like it tries to load that URL that I was like copying and pasting before, right? That was a JWT. That one, it's not that good, right? The auth request, there's just not that much information there. The second step, like once the user clicks sign in, there's an auth response that's also encoded to the JWT and it's also URL encoded. That second step includes things like the app private key, the user that signed in, the whole thing was signed by the user's key, and it includes like the profile URL, the guide URL. That used to include the profile as well, like just the actual profile, but like we quickly discovered that, HTTP servers just like will refuse to process requests.
So what if the user was an idiot and deleted his profile.json as guy hub?
So if they deleted their profile.json, they would lose a bunch of this information, but all of these URLs, so basically what's happening with these URLs is like the guide hub that Larry is using is gaia.blockstack.org/hub. Like that's sort of the base that he's using. And then every single one of these apps has a different application-specific private key. And they're only authorized to write to like app-specific buckets on Larry's Gaia hub. And the app-specific buckets are actually just referred to by these pub key hashes. Those pub key hashes correspond to the application-specific private key.
And the Bitcoin public address.
It's also a Bitcoin public address. Yeah.
I'm using very.
And
One
so
time you'll
if
use
you-
RIPE 160.
if you lost this chunk of information, right? Applications wouldn't know how to reconstruct it, but because all of these keys are child keys off of the user's key, the user can actually, like, the user's client can automatically reconstruct a lot of this, right? And so it would be able to just list all of this information off of the Gaia hub. So a lot of it would be.
So you can
historical.
regenerate, like, for
Yeah.
HMD selfie.im, you can regenerate that Bitcoin public key, it uses that part of that selfie.app, that URL, to generate that Bitcoin public key off the address.
Yes, so like the derivation path from the master key, basically just depends on hash rate.
Of that, okay, that is good. Oh, yeah.
So, if there are any other questions, or you can,
Show them like statuses that JSON, you actually hit guy, with real raw data from Gaia, that's awesome. I haven't looked at Travis.
this one's, it's not too
This is
bad.
public, yeah,
It's
so it's
just-
public data.
Yeah.
Yeah, because you can write either public unencrypted data that just the whole world can see, or
Oh, yeah, you
encrypted
do
data.
write
I don't know if he has any
encrypted
encrypted data.
I don't think it's that much.
Well, you're just seeing like a base 64 blob, right?
Yeah,
Yeah.
yeah.
Okay.
You would just see this.
Okay.
Encrypted God would be.
Yeah.
There was at some point we made one decision about like, hey, we need to make it so like we encrypt data, right, and then encode it as a hex string, like base 64.
Huh? Why is that?
Laziness.
Okay.
But this was very
Yeah,
important.
it's a lot.
JavaScript can just do two string and then hex and quotes, and
Yes.
just get that decoded, which is very easy.
And or base 64. I mean,
Or
it's
basically,
equally.
you have to say
Yeah,
that
built
in
in.
JavaScript.
Uh-huh. Yeah. If you wanted to do like base 58 for some reason, then you might have to stretch just a little bit.
Yeah.
You got a lot of
All right. Well, let's thank Aaron for the presentation. All right. And then is there any resources like where do you go if you want to chat with people about this or like
Okay.
stuff like that?
So, the best places, best resources are, well, we have BlockStack.org, that's our main website. If you want to join our Slack, which I recommend you do, pretty active community, you can go to chat.blockstack.org. There's a forum.blockstack.org. If you're looking for developer documentation, you can find that at docs.blockstack.org.
Is chat.blockstack.org, that's a Slack clone, or is it like?
Yeah, so basically it is a link for you to write your email and hit a button and then wait until somebody adds you to our Slack.
Okay. There's not like a group chat app for Slack, for BlockStack?
So.
Oh yeah, I suppose you could use.
I know. So there's peer-to-peer chatting, stealthy.im works pretty well. But with 7,000 people, peer-to-peer chatting would not be great. There is some work underway for adding BlockStack like as an authentication scheme for like Discord. But it's basically like a Slack, decentralized Slack clone.
Oh, somebody's trying to build on a BlockStack right now?
Yeah, I think part of the, yeah. Right now, Slack is kind of the best we have. But I think our plan is in more of a medium term future to be being better about creating chat. So those are the best resources.
That reminds me. Do you have is there some place where we can go for slides? Maybe you could just send me a
Yes.
URL and I'll
Yeah,
post it on the meetup site.
Yep, I'll send you the URL. I'll also post them on our forum, like forum.blockstack.org.
Okay.
With like a report for like how awesome the crowd, Bitcoin and open blockchain Chicago is.
Yeah.
You're here.
Yeah, so, everything about this slide is correct, except for the contacting me. If you contact this person, you're gonna get Larry, who's also great. A lot friendlier than me, actually, so maybe talk to Larry. If you just play Larry with Karen, you'll get me.